400 million miles from Earth, a quiet transformation is happening. For decades, we saw Mars as a world of rust and silence. But as our eyes on the ground get sharper, that image is shifting. We're no longer just looking at a planet, we're looking at a laboratory of possibilities. And what we're finding suggests that our first impressions of the red planet were only the beginning of the story. On Earth, these formations are the archives of our history. On Mars, they represent a mystery that scientists are approaching with newfound optimism. It's not just rock, it's a blueprint of a world that once shared much more with our own than we realized. These geometric cracks in the stone are instantly recognizable. They mirror the patterns we see in our own backyard, riverbeds and drying lakes. This isn't just a coincidence of physics, it's a sign of a shared language between two worlds. Look at these mineral veins cutting through the bedrock. They represent a time when fluids moved freely beneath this surface, carrying the building blocks of chemistry across the landscape. We're seeing evidence of a planet that was once geologically alive, with all the necessary ingredients circulating in a way that suggests a very stable, enduring environment. While these carbon compounds aren't a smoking gun for life, they are the essential materials that life requires. Finding them preserved for billions of years is a huge win for the mission. It proves that the ingredients for a biological story are present and waiting to be understood. This environment was neutral, stable, and surprisingly hospitable. Scientists are now using the word habitable with more confidence than ever before. We've moved past asking if Mars could have supported a story like ours, and we're now focused on discovering if it actually did. Structures like these unusual cones offer a fascinating look into the Martian subsurface. They suggest a world where gases and pressures are still interacting with the landscape. It's a reminder that even the most empty parts of this planet are full of activity. Some of the chemistry here, like perchlorates, might seem challenging to us, but science often finds that nature is more resilient than we imagine. On Earth, we see life thriving in conditions once thought impossible. By studying how biology adapts to the extreme, we're expanding our definition of where life might be found across the stars. These fine layers record a rhythm, a cycle of changing conditions that lasted for millions of years. This wasn't a fleeting moment of warmth. It was a sustained era of stability.
Recent radar data from the poles has opened up a whole new frontier. It suggests that if we want to find the most exciting parts of the Martian story, we may just need to look a little deeper. As the rover climbs, we aren't just seeing more rock. We're seeing more consistency. The same habitable conditions and the same chemical foundations appear again and again. Each meter gained reinforces the idea that what we found isn't a fluke. It's a planet-wide phenomenon.
When you look at this vast landscape, remember that Mars and Earth started in the same place, born from the same cosmic cloud. We are part of the same family. By studying Mars, we're really studying a version of our own history, and perhaps a version of our future. The paths diverged, but the connection remains.
Carbon, sulfur, nitrogen, and phosphorus. To find all four fundamental elements of biology in one place is a milestone. It's a technical green light for the future of space exploration. It tells us that the foundation is there, the chemistry is right, and the potential is real.
With every kilometer driven and every hole drilled, the story of Mars becomes richer and more complex. We aren't finding a simpler desert, we're finding a more sophisticated world. This complexity is a good thing. It means there is still so much left to discover, and every new question is a doorway to a new breakthrough. We are now designing instruments specifically to look for biosignatures, the subtle traces that remain when a planet has a story to tell. This isn't a distant dream. It's the immediate goal of our next great leap into the solar system. We are closer to an answer than we have ever been in human history.